Okay, so we're going to look at our first set of data here. So this is basketball games. We got points versus minutes. What do you guys think minutes means? It's really got to be like how many minutes someone played in the game, right? I mean, something like that. I think we got about 10 games here, so we got 10 games. We'll assume that these are for the same player, because otherwise I don't think this would make much sense. So it's the minutes that player played in the game versus how many points they scored. Okay. So first, when you're doing a set of data, you want to think about what's the independent, in other words, the explanatory variable, and also what is the dependent, in other words, the response variable that's responding to that data. So x, what do you guys think makes more sense as the x variable? Minutes. Minutes probably does a better job of explaining points than points to do of explaining minutes. I mean, there's no perfect thing there, but I think you want to think about what's trying to explain what. I think minutes are probably a better explanation. So I'm going to say minutes are on the x, points are on the y. So you don't want to always just look at something and be like, oh, the first thing is x, the second thing is y. That's like not the way to do things. Okay. So minutes is x, I think that's better, and points is y. So what I want you to do in your assignment on some problems, you guys can see that I specified on the board or on Moodle, is to make models by hand and by calculator. I'm going to emphasize by calculator because the calculator actually goes through a procedure to find the absolute optimally best line of fit using calculus. When you do it by hand, though, that's also really important. So in your quiz, I'm going to ask you to do it by hand and by calculator, so you need to see evidence of both. So if we had enough time today, I would have you plot these very carefully on graph paper. We're just going to have our calculator plot them for us, then, okay? But then once we have the plot of our calculator, we're going to first do it by hand, then we'll run the thing and see if we did a good job or not, okay? So let's plot these points in our calculator. You go to the button called Stat in the middle, then you go to Edit, just to enter. It should bring up some lists. You might have stuff in those lists, you might not. Go up to the top of the list, highlight the list, hit Clear. Clear Enter. And you do the same thing for the other one if you have stuff in there. If you go up to the top of the list and hit Delete, the list will disappear and you'll have to pay one of your friends in a more advanced class to get it back. It's pretty easy to get back these days. It used to be hard. I made some money in high school, just saying. Okay. So we decided that minutes was x, so let's go with those first. So 16, 13, 2, etc. So notice the index of the list will tell you how many data points you have. That's kind of nice. If I scroll back up, it says list 1, index 10 is 19. That means there's 10 games here. So I was right, there are about 10. So now I'm going to enter my y's. Now your list dimensions should be matched up. So if like one of these was mismatched, your calculator can't do anything. It'll throw an error. So you got to make sure you have the right number. If not, go back and check. Double check it. Make sure you've got all your data in there correctly. And then, make sure your plot is on. You need to turn your scatter plot on. So if you go second y equals, it'll bring you to your plots. Go to the very first one, turn it on. There's all kinds of different plots you can do here. The first one's your scatter plot, obviously. If you don't mess with the settings, it will just say list 1 and list 2, which is where we put our stuff, right? Our stuff was in list 1 and list 2, so wherever you have it, make sure that's what it says. List 1, mine's not list 4, it's list 2. So if I hit second, number 2 on my calculator keypad, that's where list 2 is, yeah? So to find that, I'll give you a second. Then, I think we're all good to go. If you want to change the mark, I like to make them big. If you like crosshairs, then use the crosshair guy. If you like tiny dots, you do what you got to do. All right? So I'm going to use a zoom option. Zoom standard is good for functions, in other words, curves, like we've been working with all this year so far. There's another option for data that's better. If you go down, it says zoom stat. This is a statistical technique. That's the best zoom for data. So there's what our scatter plot looks like for this guy. If I go to my window, it'll tell me what the calculator actually zoomed to. I think we're going to need that in a second. So we're going to create the model now. We've got a picture of it. Now we're going to create the model. When you guys do your assignment, make sure you plot these by hand. If you want to use graph paper, I think that's a good idea. You don't have to, but make sure you do a good drawing if you don't. There's reasons for that. We'll see that here in a second, okay? So let's draw our line of best fit. We're just going to wing it, about half of them above or below. I guess three features first. Is this, in fact, look mostly linear? Yes. Yeah, it might have a little bit of a bend, I think. But we're going to call it good enough for today. We'll say it's mostly linear. Strong, weak? Moderately strong, maybe really strong. We'll see. We'll have the calculator find R for us and see what it says, okay? But first, let's just try to draw that line of best fit on there. So I'm going to go maybe like that. It's not an exact science by just doing that. Now, I bet you guys, some of you are probably going like this more. If you're doing that, you're tempted by playing the dot-to-dot game. I'm thinking, where is it so about half of them are above or half of them are below? Mine might even be too steep still. I might need to tilt it down a little more. You guys know what I'm saying? We'll create it with the calculator and see at the end. Okay? Let's try to estimate it by hand. I need you to know how to do this by hand. So, how do you do this by hand? Well, a line is mx plus b, right? So we need the m and we need the b. Instead of saying y, though, call it y hat. Because this isn't the real y, it's a prediction. So we use the little hat guide to say prediction. Okay? So let's try to find the slope first. So I'm going to go over here and try to find the slope. You don't need to use the other points, right? You just need to try to find a triangle. Now, if you have a nice scatter plot drawn by hand, this is going to be easier. But I'm just going to say, and trace up to that spot. Well, actually, let's go to our window and get some scale here. So if I go to my window, it says x's start at negative 0.9. No, I'm going to make that a little nicer. Let's go negative 1. Make this 34. I don't think that's going to change it hardly at all. And we'll go by 5s. There we go. That's going to make it nicer. And for my y's, notice I'm not going to change them. I'm just going to make them easier to see. So my y's, I'm going to go from 2 to 44. I think I'm also going to go by 5s. Notice it didn't really change anything. I'm just cleaning it up a little bit to figure this out. If you do it by hand, it's going to be easier for you. So let's see. Once again, it went from negative 1 to 34. So this guy is negative 1. Did I go by 5s in each direction? So what's this? Negative 1 plus 5 is 4. Plus 5 is 9. Plus 5 is 13. Plus 5 is 19. Okay. So my point, let's pick an easier point. Let's go with like this one. You guys see that coincidentally is a point, but it doesn't need to be. That way it's nice at about at 4, right? And now let's go like to 14. So that looks like it hits about right there. So slope triangle. I know this side is 10 because I picked it to be nice. The only question is about how high is this? Do you guys remember what that was scaled by? Let's go back and look. It was 5s, but starting at 2. So I'm unsure. Is this 2 or is that 2? So, well, let's have a look. So if you hit trace, you can see what a few of the points are. Messed it up. There it is. Okay, trace. Oh, it usually scrolls. Mine. Oh, there we go. There we go. That's what I was looking for. So this guy is at 2. So if that guy's at 2, then this guy should be about 5 higher. We're just estimating here, so it's fine. So if you do this by hand, it's much easier. So let's see. If we go 2 to 5, that's like 7. So then another 5 is like 12. Another 5 is like 17. So this looks like a little bit more than 17. So going from 7 to like 18 or 19, how much is that? Like 10 or 11? I'm going to say 11. So through the slope of my line, I'm going to get rise over run. What about my y-intercept? Well, what's it look like it is here? That's 2 and that's 7, and this is like 4 or 5, right? I'm just estimating here. That's the way your by hand model should look. So if you're like on one of my tests or quizzes, and I can see your slope triangle, and like it makes sense, it's going to be fine. It doesn't have to be perfectly right, yeah? It should be like ballparkish. If this was like 1/2, I'd be like, what? Like that's way different than that. But if it was like close to 1, which is what this is, then you're probably good to go. Plus or minus like, I don't know, 0.3, 0.4. As long as you're kind of close. So that's our model by hand. Obviously, especially since I didn't do a nice job with graph paper and I'm using the calculator's funky scale, it's probably not the greatest. Let's have our calculator create the actual line of best fit. And then we're going to plot it, call it good for today. We'll do some more examples tomorrow. You guys should be able to start. So, if you go to Stat, same button, and you go over to Calculate, option 4 or option 8 are both ways to get your linear regression model. Doesn't matter which one you use. So I'm going to go option 4. I'm going to tell it list 1 and list 2. If you have a different menu, then just make sure it says list 1, list 2, and scroll down to Calculate. And there we go. There's the best line of best fit that it can possibly come up with. So the calculator's model is 1.0111x plus 11.154. It also tells you R. If you don't have R showing up, then here's how you turn it on. You go to Mode, and then you look around for something that says something about stat. So if you go to down, it says statistical diagnostics. If they're not on, turn them on. Go back and recalculate your model. And R will show up. There's also a thing called R squared. We'll talk about that another day. So R, 0.885. You guys were thinking moderately strong. I think you did a good job. 0.8 or almost 0.9 is nice and moderately strong. What is good about our by hand model? What's not so good about it? Mary? Slope is real good, right? Like those are really close. We did a great job. If you're that close, great. You're not going to always be that close. It depends on how good a job you did drawing. So apparently we did a better job than I thought. You know what I mean? The y-intercept's pretty wrong, though. Why is that?
Oh, I don't know. I was asking something.
Why is the y-intercept pretty wrong?
Because we were guessing like whichever whole number looked kind of like it was somewhere in the middle.
If you do a good job of drawing, your y-intercept should be pretty darn close. But it depends how good you did drawing. And also, what if your scale doesn't start at the origin? Ours, if we go back to our scatter plot, was close to the origin, wasn't it? This was like -1 and that was like 2. But what if like when you hit zoom 9, it like goes and zooms in on the scatter plot somewhere else? Then your y-intercept's going to be way off. That's why doing the model by hand is really important. That's one reason to know how to do that. Now, Kirsten, do you have a question?
I think I figured it out.
Okay. So, well, plenty of time for questions tomorrow, too. So I'm not going to do too much new. We're just going to do more examples. So the last thing I wanted to do was make a prediction. Oh, yeah, and actually draw and see if we did a good job. Remember I was saying it might need to be a little flatter? I think that's true. Let's plot that graph on there. Go to y equals. Let's graph the calculator's actual thing. 1.0111x plus 11.154. Notice, when I wrote down the calculator's model, I didn't write it down like the calculator spit it out at me. I actually like took what the calculator had and put it together in mx plus b. You need to make sure you do that. If you give me calculator throw up, I'm going to be like, that's calculator throw up. What's that? So careful with that. If we graph this, wow, I did a lot better job than I thought. I guess my experience played in. I thought it was going to be flatter than that. I got lucky. So, but notice, because we had the zooming issue, even though this looked like it was about 4 or 5, it's actually back a little bit more. So you got to be careful with that. We'll see another example of it tomorrow. So the last thing I want to do before we go today is actually use it to do something. So which one of these do you guys think is more trustworthy to actually use for predictions? Well, obviously the calculators, right? So when you do predictions, please use your calculator model regardless. Okay, so using that model that we had a second ago, which I've written up here, you want to make your predictions with a calculator model because obviously it's going to be more accurate than the one that you create by hand. Hopefully they're not too far off though, of course. I thought we'd use this model to do what the whole point of the regression exercise is in the first place and make a couple predictions. So we were looking at predicting points scored for minutes. So this one says predict points for 27 minutes played by this particular basketball player. The first step on something like this is to label whether they're asking you to predict for an X or for a Y. Basically, when we choose X as the independent variable and Y as the dependent variable, basically we're making a choice about the structure of what is explaining what and what's being used to predict what. But either way, if you're given a model and you're given an X or a Y, you can stick it in and solve for the other variable. So first is you want to decide, is this 27 minutes an X or a Y? And I think if you look at our scatter plot from a second ago, or just think about the context that we've been working with in this problem, this is clearly an X value. So I'm going to stick it in for the X in the equation. So we've got Y hat equals 1.011 times 27 plus 11. So that's going to be approximately what? Stick that in your calculator. Same thing here. So this is an X or a Y. We want to predict the points for 45 minutes. I think, again, it's an X. So I'm going to say Y hat equals that. Yep, there we go. So let's stick those in our calculator. So there's my first prediction, and I can hit second entry and just scroll over for my second prediction. So my two predictions I have so far, you want to write these in context. When you do it for your assignment, is that and that. Definitely want to make sure you get units on here, so that's points, right? So I'd say our model predicts, that model in fact, predicts for 27 minutes played that this player scores about 38 points. It's important to put that word "this player" in there because obviously this is data that was individualized to a specific person and it wouldn't apply to just any old person. This is this person's performance in these 10 games and how they're playing. Okay, there's something dangerous here in this problem. Predicting for 45 minutes, if you go back and look at your scatter plot, rewind the video or look at what you have in your scatter plot, you're going to see that 45 minutes is not next to one of the other data values that we have. In fact, it's far beyond the range of information that we have. We don't know about how this player did when they played 45 minutes because they were pulled from the game or subbed out. We don't have any numbers that are very close to 45. In other words, maybe the person will get more tired over time and something about the model would change, and instead of being that upward trend that we saw in the scatter plot a moment ago, maybe the model starts to get flat as they get more tired and they score less points. So I think that that's an important concept to be aware of. If someone asks you to make a prediction like this, you should say, well, here's the prediction, but this is a dangerous extrapolation. It's usually okay to extrapolate a little bit outside the bounds of the data that you use to construct your model, but you shouldn't be going far outside because something about that pattern or trend might change, okay? So that's an extrapolation, which I should note. Okay, let's do this last prediction. So we're going to predict for 18 points scored. So 18, is that an X or a Y value? I think this time that is a Y value, so we're going to be sticking 18 in for Y. So this time I'm going to have 18 equals 1.01. I don't know what X is this time. plus 11 and change. So this time you've got to solve by doing a couple steps. Subtract your 11 and divide by that one number. So I'm going to subtract my 11 on both sides, get my answer, and divide that by this guy. Let's have our calculator do that. So here we go, 18 minus 11. Take that answer and divide it by that. Okay, so our model predicts. Just fill in the steps here. So our model predicts that x is going to be 6.77 minutes. And you want to write that in a complete sentence on my test quiz or for any practical reason. We'll look at another example next. I'll see you next time.